Good morning, Divya. We'll wait for a few seconds so that others can join. Then we'll start today's class. Thank you, Totashri. Revise the stable and monostable multi-operator. Take a minute and go through what all we have discussed. Till that time, others will join. Don't waste your time, just go through what all we have discussed in the previous class. Take a minute and do it. Let us continue the discussion. Just revise whatever you have discussed in the previous class. So this earth table you have taken. In the earth table we have discussed. Let me go fast. Say timer output is a high, flip-flop output is low, Q1 is off, C1 starts charging towards the VCC through R1 and R2. This is high and this is low. Observe the slide. This is Q1 is off. Hence the next is capacitor will start charging. So this is just a revision for your reference. So last class we have spent a time to discuss this. Try to understand within a minute. So this is the way how this works, and after this then you can take a 30 seconds and just go through once again. Then after this we'll go to the next slide. Now there it is now 2/3 VCC, and when it goes to the 2/3 VCC above, op-amp 1 will give the high, flip-flop output becomes high, timer output becomes low, Q1 conducts and C starts discharging through R2. Observe carefully. Once again, it is a revision for you people. Here this is a high, output is low, and flip-flop output is high, Q1 conducts. So therefore when Q1 conducts, this capacitor will start discharging. So this is we have discussed in the previous class. So please try to understand. Once again I am doing the revision for your reference. So try to understand this. After this, and we have when VC becomes less than 1/3 VCC, op-amp 2 will give the high, flip-flop will become 0, output of the timer becomes high, and Q1 is off. Therefore again C starts charging. This is high, and because of this high, this is low. Because reset, output timer of high, and transistor becomes off. When transistor becomes off, C starts charging. C starts charging. So this we have discussed in the previous class. Once again I am doing a revision for your reference. Try to understand. It's very simple. Then we have discussed the monostable. Say output is 0, flip-flop is set, Q1 is saturation, and therefore VC equal to 0. Try to understand. Observe this. First is low output, high flip-flop output, Q1 is on, therefore capacitor voltage is 0. Next we have discussed when I give the say trigger, positive going trigger, say towards a 0, that time op-amp output of the 2 will become high, flip-flop output become low, and timer output becomes. All the steps are given. Try to understand. Now this is high, and therefore this will become low, and this becomes high. Therefore the transistor timer output is high. Therefore now Q1 is off. Because of that, C starts charging through resistor. This we have discussed in the previous class. Once again I am doing the revision so that at least stable and monostable will become perfect. So you should be able to understand whether the 305 timer you are using in the stable or monostable. Then after this we have discussed in the last class. So when it reaches greater than 2/3 VCC, op-amp 1 will give the high, and flip-flop output becomes high. Therefore timer output becomes low. Q1 conducts. When Q1 conducts, we don't have any resistor at all. Because of that, what will happen? C discharges suddenly. C discharges suddenly. There is no time constant because R equal to 0 here. Therefore, suddenly it will discharges. So this we have discussed in the previous class. Now coming to the next, I asked this question whether the stable is 0 or 1. I'll wait for 50 seconds. I want you people to type your answer in the chat box. Very good answers. Everybody is telling the answer, and very good to see all the names. Manjunath, Nischal, Sriharsha, Divya, Nayana. Everybody is telling 0 is a stable because it will remain in the 0 only until and unless I apply one more trigger. Therefore, 0 is a stable state. Very good. Happy to see your answers in the chat box. And the last class I asked you people to note down this, and t equal to 1.1 RC. That is a time it will be on. So this is the equation. Last class I told you to note down. Hoping that you might have copied. Otherwise, I'll give one more minute. You can take a snapshot or you can copy it if you have copied half already. Take a 1 minute. I'll wait for you people to copy. This is a monostable multi-operator. Somebody was asking, sir, we don't have a lab, what to do? I'm doing in the simulation. See, a lot of simulators are available. Just do the simulation. This is a monostable. I have done the simulation, and whenever I apply the trigger, so this is going to a positive. During that time, a charging is taking place. And these are some of the applications of a 555 timer in monostable mode. A pulse width modulation, frequency divider, linear ramp generator, missing pulse indicator. You can just copy down. Take a minute and try to copy down at least the names. Hoping all of you have copied this. Let us go to the next. What do you mean by duty cycle? Let me take another 1 minute. What do you mean by duty cycle? Okay. On off delay. Sita is telling, but Abhinandan is adding some line. Very good, Abhinandan. Upon our ratio of a T on by T off. Very good. Anybody else want to say something? You are most welcome. You have studied already in your 3rd semester. A pulse width modulator. We will not discuss the application in detail. Simply observe this. Pin number 5, I am applying some voltage. When I apply this, 2/3 will change automatically. My outputs will also change. Okay, very good. Many students are typing the ratio of circuit on the circuit on and off. Okay, somebody is telling on and off. It is the same circuit I am showing you. And this is a waveform. When I give a pin number 5 like this, automatically my timing will change. That is what we can observe. A duty cycle, many students are telling, I will give the 1 minute, you can just go through. It is somebody told, sir, T on by T off. Yeah, it is correct. It is duty cycle equal to T on by T off plus T off. When I say 50%, automatically T on equal to T off. Therefore, 1 by 2 you will get. This way you will get a square waveform. So this is what you might have studied already in your lower semester. And stable, if they ask 50% duty cycle, what changes, what modifications you are going to do in your circuit diagram? Can you tell? I will give 1 minute. This have been already discussed. How to get a square wave from the stable, it is already discussed in the class. I want you people to recall and type that in the chat box. Yeah, Rakshita, it's correct, but how to do it? What modification you are going to do in whatever the circuit diagram you have discussed? For that, what changes you are going to make? It is already discussed in the class, previous class. Very good. Totashri is giving the answer. Very good, Totashri. We use a diode. And it is already told to you people. A diode will conduct, that time only R1 will come into picture. When discharging, R2 will come into picture. If you take R1 equal to R2, you will get a square wave. This has been already discussed in the class. Very good, at least we have 1 or 2 students who are remembering. These are, I have just simulated how a pulse width modulation using op-amp can be done by giving a different waveform. And these are the 555 timer in the stable and monostable. What are they good for? Stable is good for clock, timing, signal, and monostable you will get a clean pulse whenever you want to switch on a particular bulb or anything for a particular time period. So you can go for a monostable, you will get a very good pulse. Take a 1 minute or less than 1 minute, just note down something. So let me go to next. Anybody knows whether the resistance of a 100 watt bulb will be more, 60 watt bulb will be more? Can you tell something? I'll wait for 1 minute for you people. These questions I am asking every year to the students, but in 2013 some student has answered. I'll tell his name in the next slide. Whether 100 watt bulb resistance is more or 60 watt bulb resistance is more, you can tell. He is a Santosh Huggi. He is working in Delphi, 2013 alumni batch. He prepared this and he has given. Whether right or wrong, you people can check, cross verify also. Hope screen is visible. Now I have shared the slide. A to D converter, D to A converter we are going to discuss now. And most of you know these things. Everything is analog in the nature. For example, if you take a temperature, it's analog, speed, position, anything you take, all these are analog. But processing, we do it in the digital. All of you know, processing is done in the digital. Hence, there is a need of conversion from analog to digital before we go for a processing. After processing, I want to use means again I need a analog. Say for there also I need a digital to analog converter. Hence, ADCs and DACs are very important, and in this chapter, the different types of A to D converters and D to A converters we are going to discuss. Digital systems are used to process the information. Couple of major examples, many examples you people know, CDs, MPCD, everywhere we store in terms of bits only, digital only. But actually sound is not a digital, it is purely analog. What I am talking is analog, but I store it in the digital. So the same thing is given in brief for you people. Say I am talking, I am converting that into a digital that I am storing in the system, and I will do the processing whatever I want. Again I will convert D to A, again I use the speaker, and again I can listen it. So I am uploading in the YouTube, but everything is a digital when I am processing. When I am storing, everything is in digital, but when I am end is again analog, but the input is also analog. So this is the way how we use the A to D converters and D to A converter. This one should know. Understand this. It takes an analog input, A to D converter, generates a digital output. The more bits the output word has, the better the resolution. So for example, 0 to 7 volts I am giving input. I can use only 3 bits, I can use 4 bits, I can use 5 bits. As the number of bits increases, automatically the resolution will also increases. Try to understand this particular point. Let me, this we have discussed many times. Say I am giving some voltage V reference by 2 will be the now inverting terminal. V in I am applying. V out will be VDD. I mean to say plus V sat. When V in becomes greater than V reference by 2. If V out will be definitely 0 because this minus V I am not giving, ground I am giving. When V in becomes less than V reference divided by. This is a basic fundamental one should know, and we have discussed this many times already. This is just for your reference so that later we are going to make use of this particular concept in our circuits. Share this information in your WhatsApp. Tomorrow I will conduct a quiz. Ask all the students to attend it. Let us go to the next. Resolution. It is the smallest analog change that can be distinguished by the A to D converter. And usually quantization noise will be there. It is a plus or minus 0.5 LSB, least significant bit. We call that much of uncertainty will be there. We have different types of A to D converters. A few A to D converters we are going to discuss. Those are single ramp A to D converter, and we have a counter type A to D converter, successive approximation A to D converter, flash A to D converter. We have a dual slope A to D converter. One more is there. Take a 20 seconds, just copy down. In detail, one by one we are going to discuss. Now we will discuss one by one. Let us take a single ramp A to D converter. I want you people to copy down the diagram. This is completely drawn by me. Each and every single line is drawn by me. You won't get this in the internet. I am taking a lot of pain to draw all these things. Okay. So please copy down this neatly. Then we will have a discussion. How actually A to D conversion takes place. Hope most of you have copied. You can say done so that it helps us to go to the next slide. Very good. Thank you. Let us go to the next. Working we'll discuss now. Before I go for working, I want this answer from you people in the chat box. This is a 4 volt. When this is something X, when X is this much, output is high, sir, or low. I want something you people to say. When V0 becomes high, when V0 becomes low. Say X, I am giving some voltage. I want you people to say when V0 becomes high, when V0 becomes low. Always is telling, and less than 4, sir, automatically it is a high. Very good. Many students are typing in the chat box. When this is less than 4, automatically this will become high. If this becomes more than 4, this will become low. Many students, they are telling the answer. Very good. Happy to see your answers. And if you understand this, remaining will be very easy to understand. Now, try to understand the working of this. Initially, as given to the reset to the ramp, and this is 0, and counter is 0 because we are sending a reset signal. So counter is 0. Please keep your mind in on the slide. Try to understand. Hardly 5 minutes it will take to understand. Initially this is 0, this is 0. Next step. Comparator compares inputs Vi and ramp voltage. I am applying these two. This is a ramp voltage, this is a 4 volt. Simply I am taking for example. Now initially it is 0. Therefore, try to understand, when I am applying this 0 volt, what is the output of the op amp? Is it high or low? Now this is a 0 volt I am applying. This is a 4 volt. Whether this will be high or low at point number 3. Is it a high or low? High. When this becomes high, very good, clock will reach the counter. I repeat, please try to understand. When this is high, clock will reach the counter. Counter starts counting 0, 0, 0, 0, 0, 1 like that. And when this starts counting, try to understand. Up to this, now you copy down and understand. If you feel difficult, you can ask. The next explanation will take a next slide. Now, as a ramp voltage V exceeds Vi, if this is increasing continuously, observe this, see here. When this becomes more than 4 volt, output of the comparator becomes low, this is disabled, counter stops counting, control logic is having low, that will send a signal to the latch as well as it will reset the counter. Observe carefully one more time. I am showing you, when I am applying this becomes greater than 4, op amp output becomes low, this is greater than 4, this becomes greater than 4, automatically op amp becomes low, this is disabled, counter stops counting, and control logic will send a latch, then it will send a reset. That's all. It's very simple to understand. Points are given, point numbers are given, even animation I have shown. Copy down and understand. Very good. Most of them they are completed. Happy to know. Let me go to the next. Any doubts if you have, you can type your question in the chat box. Now, it's a block diagram. If a clock, say consider if I am changing the clock frequency, whether output will change or not, you can type the answer in the chat box. Now say, just for a reference, I am giving a 1 kilohertz now. Suddenly I will make it as a 2 kilohertz. Whether is it going to change my output or not? Yes or no? Some students are telling same. Okay. No sir. Very good. Pawan is telling different answer. Thank you for your answers. Same. It will remain same. Think, use your common sense. Simply don't type seeing others' answers. Think and say. No. Rajat is telling not same. Rakshita Karnam is telling. Very good. Use your common sense. Just use a common sense, because say for example if it is taking a time, say x millisecond from reaching from here to above 4. That time when I give the 1 kilohertz, next time if I give the 2 kilohertz, whether the output will remain same or not. That is a question I am asking you. Remember, it will change. Then how to give, sir? After calibration, for example, when I am giving you the 4 volts here, this is fixed ramp. I should get a 4 number here. Like that I am choosing a clock and I will not change the clock. So this is very important. Take 1 minute and try to copy down one line from this. Let me go to the next. Now a counter type A to D converter, second we are going to discuss. It is the same, those who understood first one, nothing is there in the second one. But take 1 minute and copy down the diagram. Working we will discuss after a minute. Now try to understand. Let us go to the working. See, binary counter is reset to 0. This is reset to 0. And output of a DAC is 0. See here. And DAC output will be 0. It is the same what we have discussed. Now this is high. Because this I am giving like a 4 volt something. This is 0. This is high. When this is high, clock will reach the counter. Counter starts counting. Very simple. Counter starts counting. It is the same what you have discussed. Now your time starts. You can copy down the few steps. We will continue the discussion. I am repeating. Try to understand. The reset 0, output is 0, this is a high, clock will reach the counter starts counting. Now let us go to the next. When Vi becomes less, or when this input becomes more than Vi, output of the op-amp will become low. So try to understand. The same thing I am going to discuss now. This is a greater than becomes 4 volt automatically. This is 4 for example. This will become low. When this becomes low, AND gate disables and counter stops. When counter stops counting, latch is sent by the control logic. It's a block diagram. Just some of the information we may not be putting. And it will send a stop to the reset to the counter. Okay, the second stop you take it as a reset to the counter, and this you try to copy down and understand. It's very simple. So we have discussed first one. It is also same, but there the ramp was it's a linear. Now it is a stepwise, like that changes there. Remaining operation is almost same. This is a reset you copy down. A disadvantage is speed is low and DAC must be sensitive. Just copy down and try to understand. This is greater than, say, less than 4. Once if it becomes greater than 4, it becomes low. This disables, this stops, this send a latch control logic, then it will send a reset. That's all. Now I am asking you same question. Initially a 2 kilohertz was there. Now if I make a 4 kilohertz, just for an example, output will remain same or change. So this is a complete working. Once again we can go through. Just read it once or twice so that it will become easy to understand, to remember. So today we conclude the class. Now next class other remaining A to D converters will discuss. And if you have any doubts you can ask. I will be here for another 5 minutes. And if you don't have any doubts you can leave the meeting. Thank you. Take care. Be safe. Have a good day. Bye. Yeah, it remains same, Rakshita, correct. Thank you.